Hello everyone, my name is Jiaxiang Li, and this is my CGT 147 skill 6 to create some effects to show the relationships between SOP network and DOP network and how we generally use these effects to create multiple types of visualizations in Houdini to use them for the industry design and products. So before we actually go into the workflow, I'm gonna explain some of the basics about the relationships of SOPs and DOPs networks and how we're gonna create this. So first we need a some SOPs network, which basically we are gonna create our original geometry and our environment where the effects will be taking place in. And in the second part, we'll create a DOP network to perform the calculation and also to add multiple relationships between each of the effects and objects. And finally, we're going back to the SOP network to import all of the data from DOP network using node and stuff. The things we're gonna render and export from this project is the third SOP network, and we're also using this to create shading and texture and stuff like that. So the main difference in terms of how the nodes works in DOP and SOP network is that in SOP, which is how we're gonna create our geometry, nodes are kind of connected to each other to transfer all the information from the previous nodes to the next node. But in DOP network, things more kind of look like a graph. You jump from one part to another part to perform calculations and effects. So in this assignment, I'm gonna create effects about maybe a water slide in which water are going to come from a source and flow down a slide, and we're gonna put something more to it, maybe emitting some smokes or fire or particles, and we're also gonna put objects into the water slide to make it slide down within the waters. So first we're gonna create all of the basic structure of our effects. So first we're gonna create the first SOP network, which includes all of the geometry like the slide itself, and also we're gonna create another geo node to contains all of the information of the source of all of the effects, which is gonna be a sphere. And I'm just gonna hold them in one folder. I think it's called folder. Let's name it to SOP. And then we're gonna transfer all the information from this part to a DOP network. So I'm gonna just put down this node here and call this DOP. And lastly, we're gonna transfer all of the DOP information to a second SOP network. It's gonna based on how many effects we're gonna add. So I'm just gonna add one of them here and call it SOP output. So that's basically the structure that we're gonna create our effects based on. Now we're just gonna uncheck all of the display flag of the later nodes. We're gonna just focus on our modeling first. So for the slide, I'm gonna use something to create this model. We're gonna put down the box here, and we're gonna change its parameters into something thinner like this. And let's just change its place center to somewhere higher. And then we're gonna select two primitives, and we're gonna transform it, maybe increase the distance a little bit and increase the inset to create all of the handles on both sides of the slide. So I'm gonna create this like that, and the second part will be the handle itself, and make it a little bit smaller and maybe add another poly extrude to make it thicker, more like a geometry. And now I'm gonna create the sliding part of the slide. So for now, I'm just gonna select, maybe select the front view, but apparently it's not facing the front, so I'm gonna change its rotation, rotate to here. So now it's facing the front. No, we're just gonna select the primitives here and go back to perspective view and use another set of poly extrude from transform, yes, and we're gonna translate it in the positive axis of z-axis, and at the same time we're just gonna translate it down, maybe to 1. No, that's 2. Maybe we can make it steeper like that, and we're gonna create the second part of slide, which is kind of not that steep, and we're gonna create the third part, which is the last one. And that looks pretty good. And then we're gonna create all the feet for the slide. So we're gonna use poly extrude node to some point of the slide to make it extrude down to the ground. But first I think we need to create the wall of the upper part of the slide, because there are always a wall to make for the safety consideration. Maybe we can only extrude these 2 parts, but apparently we also need a back. If we don't have a back, the slides is just gonna be opened from both sides, which is not very pleasant to watch. So for that, I think we're gonna select all of the primitive in the back and extrude it a little bit here, just a little bit. And we can select not from the top. I don't know why it's reversed here, but so we can select the upper side of the back and extrude it up using transform. Maybe we can also select the side of the slide to also create the handles. Okay, that looks pretty good. And we can also utilize the bottom part, the 2 little primitives in the bottom, to extrude it down to earth. And probably we can add the feet on the front too, because that would be more physically logical. So we're just gonna extrude like that too, and select the 2 little parts, little primitives, and also extrude them down. And then we have something like this, which is, at least is a slide. So that will be our environment in which our effects will be taking place on. And now we will add the sphere to our slide, and after that we can create our effects in DOP network. So we just gonna wait, but first I think we can make the slide more aesthetically pleasing by using a node called I think it's called subdivide. Yes, subdivide. And we have something like this, and maybe you can try to change the depth a little bit, but I think 1 is perfectly enough. And now it's more like not very sharp, not too sharp, and we can put our sphere to the environment, and we can decrease the uniform scale of the sphere down to like 0.1 and transform it up to the top of the slide, maybe a little bit higher. And maybe I'm wondering if that's too small for the effects, but it's okay. I think we can change it after we add effects too. So that will be the basic modeling for the first SOP network. So what we need to do now is to use the second network, which is DOP network, to add multiple effects to the environment emitted from the sphere we just placed on the slide. So if we want to perform each kind of effects to the sphere, we need to first transform the sphere into a volume. So in order to add different effects, so what we need to do is to add a node to the sphere, which is fluid source. But we can see that there is no fluid source that we can search. So what we can do is to use the shelf tool. So what we need to do is to right click on the shelf, and if we see edit shelf tab, we can click on it and choose tools, and we can browse all of the tools in Houdini using this interface. And we can find F, so we can find fluid source, and we can add to it just by clicking it. So we can see that there is a fluid source in this tab, which originally it didn't have. I just manually added to it. So you guys can do this too if you want to access to different type of node that you want to add. So what we need to do now is just to drag the fluid source to the geometry interface and connect it together. So first thing what we want to do is to add some fluid water kind of effects. So in Houdini, we call it source flip. So we can see that the sphere now turned into other kind of stuff which is bigger, and it's kind of more volume instead of polygon. So this is our fluid source. And if we want to make the fluid more like detailed and more realistic, we can always go to the settings here and change the division size to something lower. And we can see that when I changed it to 0.02, it became more spherical and more detailed. That's because basically it have a bigger like resolution. And basically we don't have anything else here to edit, so we can just put it into a null node, and we can name the null node as out flip, so that when we want to reference fluid source for the flip object here, we can just reference the null node. And now that I think about it, yeah, we can also add a null node to the slide and name it to out slide, so we can reference both of the materials, the geometry, in the DOP network if we want to. Make it more clear. So when other people like see our project, they will not be confused that much. So now let's dive back to the DOP network. So we see that if we want to like use effects like that, we need to first utilize the output to connect different kind of nodes to it. So basically in DOP network, we have many kind of solvers, including like blend solvers, bullet solver, crowd, like flip and pop, pyro, RBD, and stuff like that. And we'll cover like 2 or 3 of them in this video. So some of the solvers that we use very frequently are flip, which is fluid, pyro, which is fire and smoke, particle, which is pop, and rigid body dynamics, which is RBD. So if we want to structure a proper solver to make it work, we need to utilize in a total of 3 nodes, which is the solver node, the object node, and also the volume node. So if, for example, if we want to use create a fluid effect, so first we need to add a flip solver, and to the first input point we need to add a flip object, which is the object node that stores all of the information of the fluid. And to the last node we need to add a volume to reference the sphere that we just created. And what we need to do now is to connect the flip solver to the output so that we can see all of the stuff going on. And once we did that, we can see that there is a cube of fluid down there, which is not what we want, because that's sort of the basic default path for a fluid. So we just need to delete this in the initial data, because we want to reference the volume, which is the sphere we just created. We need to go to the volume source. But for now, what we need to do first is to restrict the area of the fluid, which is represented by this box. So we can always change its size, maybe from the top view and from other views, to make it fit the simulation we want to create the best, and just reduce our computer's pressure of rendering all of the stuff as much as possible, because we don't want to make it too laggy to just stop performing our simulations. And now I think that's more than enough, and our fluid simulation will just taking place here. Let me just trim it down just a little bit, and here, that's enough. So let's go back to what we just talked about to reference the fluid path. And for first, we need to tell the node that we are referencing flip, and then we need to choose the path, which is the out flip. And now we can see that there's some kind of fluid clustering in the same place of that sphere, which is good, because that means we reference the correct thing. And for the convenience, we want to first change the visualization types from sprites to particles. So now we can see that the screen is not that clustered, and we can see the source of the fluid pretty clearly by looking at all of the particles in the place of the sphere. And let's play it just for one time or two, and we can see that nothing's happening. That's because we haven't used any kind of gravity forces yet, because we wanted to simulate the actual environment, so we need to have a gravity, or else it's just gonna stay in the same place. And we just need to add a gravity node and hit play, and it looks pretty good. It's not interacting with the slide, but at least it's falling down. So now what we need to do is to make the particles, which is the fluid itself, interact with the slide. So how are we gonna do that? Because we can see that in DOP network there's multiple kind of solvers which process all of the data and make it simulate the right thing. So there must be kind of a solver for slide too, yeah. So because slide is kind of static, we don't want it to move like anything else. So what we need to do is to add another solver called static solver, and we will use that to process our slide. So before that, we need to know one thing, particularly about the node network in Houdini, which is the way Houdini processes data. Because Houdini processes data from left to right and from top to bottom. So we need to change all of the positions of the node in order to make it process the right thing. So what we need to do here is, because we need to first process all of the data in the slide and then simulate all of the fluid in flip solver. So we need to first let Houdini process the static solver, which must be on the left. Then we'll place all the flip solver on the right, so that the fluid will not ignore the existence of the slide and flow through the path. To confirm its order of processing stuff, we need to check on the merge node too, because we see that if we want to process the static solver first, we need to put them on the top of this box, which is input operators. So we see now we can have static solver on the top when we can confirm that the Houdini will process the static solver first. So what we need to add here is the same to the flip solver, which is static object. So we can see that in static object we want to reference the SOP path, which is slide, which conveniently we just add the outSlide null node, and we can see that the slide is not ghosted like before. So we can see that it's actually processed in the DOP network. So if we come to the physical tab here, we can change its physical properties, but for now we just need to hit play and see what's going on. And nothing has changed, which is not what we want to do. So we can see what's going on in the collisions, because we want to make all of the particles, which is the fluid, collide with the surface of the slide. So we can see that in the bullet data, we can see that we can click on the show guide geometry, which is how the slide will perform in collision. We can see that its shape's not like the slide, it's kind of like too big. So what we want to do is to change its collision to concave. So we can see that the guide geometry is the same to the slide, but still nothing's happening to the particles, which is probably not the bullet data's fault. But we can see that here. We can see that particles actually influenced by the slide a little bit. So there must be something else going on. Maybe we need to go back to the RBD solver. On the volume, we can see that if we turn on the collision guide, we can actually see that there's a little part of the slide that's actually being processed as a collision. So like in this part, we have the collision parts, and apparently it's that part that influences the particles that make it bounce to the front. So we need to do is to change its offset surface bigger. Yeah, and we can see that it's pretty good, but I think the collision surface is too big. So we can like change its tolerance maybe. Still it's pretty rough here, but we can see how. But still, yeah, it actually looks pretty good. But yeah, but all the particles you can see here is floating on the top of the slide instead of actually colliding in it. So let's see if we can deal with that. Let's turn on the collision guide again and maybe change its uniform divisions so that it might be more precise, and change the data of the offset and tolerance. We can see that now it's pretty accurate. And let's go in here. Okay, and now I see we can see that it's pretty accurate in terms of how the particles are collided with the slide. And now we can change some of the physical properties of the slide. Maybe change its bounce to 0, because we are dealing with fluids here, we're not dealing with actual particles. So we don't want it to bounce like that. And bounce forward maybe a little bit lower to maybe that's a bit too low, maybe 0.5. And maybe we can change the friction to 0. Yeah, it looks better, but not the best thing we want. Maybe bounce forward a little bit higher, 0.75. Yeah, it's like water, but it's like the viscosity is too high. Maybe just change to 1. Let's see what's going on here. Whoops, accidentally set a keyframe here, but we can use control click to cancel it. And we can see that when using 1 of bounce forward it looks much better, much like actual water slide. So we can use that as what we want. as the physical properties of the slide. And actually, in this video, I'm gonna delve deeper into the details of the fluid, because why not? We want to use it to create more realistic, more impressive simulations. So in flip object, we chose properties here. And if we want more a detailed fluid simulation, we can actually change that by changing its particle separation a bit lower. So here we can see that we changed it to 0.0, maybe 0.3 first. And now we can see that particles are much more dense than before. So after we run all of the frames, we can see that the simulation is actually good and very accurate to what water will behave like in a slide. So that's pretty good. Maybe we can even delve deeper and change it to not now, but just to mention it, I think there in the fluid source that we create for the geometry, which is a sphere, we can see that there's also a particle separation. Maybe if we change that to 0.02, and that's a little bit too much work, don't you think? So maybe we can use a little bit of like reference here. We can just right click it and click copy parameter and use the parameter references here in the DOP network to paste relative references. So yeah, maybe use that references, we can make both particle separations in both parts consistent with each other. And for now, they're both 0.02, and we can see how the simulation is going on in the viewport. And we can see that, yeah, the fluid is really dense, and there's almost like a tsunami effect. So maybe, yeah, that's what we are going for this video, and I think I want to make it as good as possible. And for now, it's pretty great. And we can zoom in and see all of the stuff going on, which is completely burning my computer, so yeah. So temporarily, we can change it back to sprite and see what's actually are going on, which is a chaos, which actually doesn't look like fluid, but we will deal with that later. So for that's our flip, which is our fluid simulation. We can just for our computer's CPU's sake, we can just turn it off by disconnecting the nodes. And for now, we want to do is to add another effect. We have just add water effects. Now we can add some smoke effects. So for smoke effects, we can also use a fluid source, which is weird, but that's how it works. And the only thing we need to change here is to initialize the container settings to source smoke. And that's basically what we need to do here. And for smoke, we didn't want division size of too low, because smoke is just smoke. Yeah, we don't need that to be too accurate. We just need a bunch of gray stuff in the viewport. So we can just use a null node to make it clear and name it out smoke. So let's just bypass this fluid source to make our simulation quicker, and let's dive back into our DOP network. And we can turn off all of the displayed flag of all of the SOP network nodes, and we can only see the stuff happening in DOP, which is good because we want to know what's actually going on, what's going wrong, what's going right in our actual simulation. And just like static solver and flip solver, we need another solver for the smoke too, which is pyro solver. And same as the previous two, we want to add extra node on top of it, which is smoke object, which is not a pyro object. And another thing is the volume source, just like flip solver. But first we can just, because we want to like don't mess up the simulation, and we want to make sure that the static solver is on the prominent place, the first place to process, we can just add all of the stuff that can be affected by the static objects into a merge, and merge all of the stuff here and connect the merge node to the first merge node. And we can see that the static solver stuff was actually in the front, so no matter what we did to the second merge, the static object will be processed first. And let's go back to the pyro solver and add the smoke object here to the first input and the volume source for the last input. Every stuff is basically the same. We need to reference the south path, which is our smoke here, and basically that's what we need to do, but apparently we don't have a smoke going on here. And let's check out why this is happening. Let's first disconnect the flip and play. Apparently there's no smoke. I know, maybe I know what's going on. Because similar to the flip object we just talked about, smoke object also have a container, which is the stuff here on the bottom of the slide, and only smoke in that container will be processed in the DOP network, because we all want to save our CPU and GPU. So we can see that in the SOP network, the smoke stuff is actually on the top where the sphere is at. But in the DOP network, I don't know why, but they're automatically set to the bottom here. So what we need to do now is to just simply change the position of that box up here and adjust it according to the smoke. But let's just make it bigger here and see if we can see the smoke here. And here you go. The smoke is perfectly fine, and we can see that it's actually interacting with the slide 2, which is double good. So that is a pretty weak smoke, but maybe that's fine. So for now we can just adjust the container to something more reasonable, and that will be our smoke for this video, which is not very stunning. It's just smoke, but that's how we kind of produce our smoke in pyro solver for this video. And you know what, actually after seeing all of the simulation in the 50 frames, we can actually trim the smoke's container down to here, because we can see the smoke is not moving pretty fast, it's only moving here. So we can change here to save our computer's calculation speed. And now we can connect both solver to the second merge, and we can see the both effects happening at the same time. We can see the crazy fluid coming down the slide, and inside this fluid we can see all of the smoke just getting immersed into all of the blue water particles, which is actually pretty cool. And maybe that can be used to create something like a smoke water in water slide, I don't know, but yeah. And now I'm gonna just create the coolest effects for this video, which is I'm gonna add objects that's initially on the slide and make it flow down with all the smoke and fluid together, and make it collide with all the particles and fluid and smoke. So we are just gonna add a box here and put it right on the slide here, and let's see what we can do about that. So that's pretty simple. So we just gonna dive back to our DOP network, and remember that just like a slide, we are gonna make it interact with all of the flip, all the fluid and smoke. So we are not putting this object to the second merge. Instead, we are gonna create a new merge that merges the static solver and this box together to make them interact with each other and at the same time interact with all of the fluid objects on the right side. So we are gonna create another merge here, named to merge objects, and the second is merge effects. And we can make sure that they're in the right position, and we can add a new solver here. The thing is, the box we are gonna use for this video is not a static object. So it's gonna use another solver, which is called RBD solver, which is rigid body dynamics. And we're gonna add that here, and accordingly we're gonna add an RBD object. So here we just gonna wait. We haven't created a null node for the box yet, right? So we're gonna go back, just for consistency, add a null node, maybe change it to out box, and go back to DOP network, and reference the solve path with the out box, which is in the box geometry. Here we can see that it's added to the viewport, which is good. And okay, I forgot one thing, that we need to check on the objects merge node too, because we want to process, even in this node, we want to process the static object, which is slide first, so that we won't see the box clipping through the slide and fall down. Yeah, that's pretty good. And we can see what's going on here. Yeah, the effects goes pretty smoothly. The box just slide down the slide, and I just can't wait to see what is gonna interact with the flip. And let's connect here and play. Yeah, that's very cool. We can see that the slide and the box here actually block all of the particles of the fluid and slide down with them. And actually for visual purposes, I'm just gonna change the box to something else that's more interesting, more complex. Actually, I can change it to template head. Just imagine that the head is falling down through the slide, just like horror movies. And we can make it bigger. Maybe that's too small too. Maybe change the uniform scale to 1.75. Maybe just 2. Okay, that's enough. Look at that. That's pretty good. We can see that all particles are kind of falling onto the head, and also the head is blocking all the path here and flowing down with all of the particles. And just to mention it quickly, we can actually change something else for the head. We can add an initial state for the head too. Maybe we want an angular velocity of some random numbers, make it spinning all the way when sliding down with the fluid, and we can initialize the velocity. We can change it to y equals to 2, so we can see the head bouncing up in the beginning and sliding down with angular velocity, spinning all the way down. Maybe we can change up the x velocity and z velocity too. Maybe that's a bit too much. We can change back to the particles. I don't know why it's changed back to sprites, but we can change something lower. That's too wild. We cannot see the head altogether. And for now, I think that's a really cool state, really cool effect. Yeah, just for visual purposes, that's very satisfying to watch. Yeah, we can see that the head's bouncing up and sliding down and spinning at the same time. So I guess that's all for the RBD object. And lastly, the thing we want to add is particle. Even though we have actually witnessed all of the particles in fluid objects, but we still want to see the actual particles and how it can be set and behave in Houdini's DOP network. So in here, the solver we want to use here is actually not a particle solver but pop solver. And accordingly, we want a pop object and a pop source. Surprisingly, it's not a volume source but pop source. And after connect it all together, we can see here's the SOP we want to reference. And the special thing for particles is that it doesn't need a fluid source. We can just add sphere here and reference the sphere itself. So there's nothing going on because we haven't connected it to the merge node yet, but we can change some initial state like emission type to all point. So we can see all particles emitted from all the points on the sphere geometry. And after hitting play, we can see that the particles is behaving, which is a very interesting behavior. We don't want that. That doesn't look very dynamic. So we can change, maybe go to pop solver and maybe pop source. Yes, and here we can see the burst tab. We can change the life expectancy to 5 and maybe add some life variance, so there will be more possibilities. And another thing we want to do is to change some of the inherent properties of the particles, which I'm gonna find somewhere to add these properties. Oh yeah, we don't need to use inherited velocity. We need to change it to set initial velocity. Yeah, and here we can set the initial velocity and here we can have something much better with some variance here. We can set up a bigger y variance. It can be, yeah, we can also set a variance of x-axis, which is just pouring all of the particles down here, or the z variance, or the z velocity, and we can see that it's bursting particles, and we can see that there's a big difference from the fluid particles because they're just different. I don't know why, they're just different. And that's basically what we need to do for the particles, and we can see what's going on when 3 stuff are emitting together, and we can see all of the spectacles going on here. Maybe we're just gonna change fluid to particles, and we can see all the particles, the flip and the smoke going on together, which is lagging pretty much, and my computer's fan is like going crazy right now. And yeah, that's basically what we need to do for our DOP network. We basically covered everything: the static, the RBD, the flip, the pyro, and the pop. So for now, what we need to do is the third part of this project, which is the second SOP network that is used for the output of everything we just did, because we want to retrieve all of the data processed in the DOP network and render it out with textures and shaders. So we first need to add a geo node, and we can name it to, because we first want to import our slide for the setup of the environment, so we can name it out import slide. And for objects like slide and rigid body dynamics, we want a node called object merge, and it said that it wants us to retrieve the path of an object, which is in our case the slide. So we can go back to the slide and put down the relative references, and you can see that slide is right here. So the next thing we want to import is the flip, which is the fluid we just created. And for things that's gonna interact with the objects, like fluid, like particles, and like smoke, we want to use another kind of node called DOP import fields. So for this node, we are gonna first they ask me for a DOP network, which is DOPNet1 we just created here. And the second is the DOP node that we are just gonna retrieve our data from, which is, we've talked about before, the node that stored all of the information of the simulation is the object node, which is, in our case, flip objects. And the last thing we want to do for DOP import field node is to choose the preset of this node as flips fluid. So we can see that there's all of the fluid particles running down the slide, just like we saw in DOP network. And that's pretty much it. And if you look at the fluid closely, we can see that there's actually space. That is a result of the interaction with the head. We can see that there's a space there in the beginning. That's because we only retrieve the data from the DOP network. We are not retrieving data just from the beginning, because the data we retrieved are already calculated the existence of the head and other objects. So for the third import geo node, we want to import the smoke. So as same as the flip import, we want to add a DOP import field. And this time, just like the node for flip object, we want a DOP node. Oops, I pasted the wrong thing. I need to put that into DOP node and just paste the DOP network references on the top. And for smoke, apparently we need to choose smoke for our preset. And let's try to take a look, and it looks just perfect. Then we can move on to the next geo node, which is particles, which is the pop. We can repeat the same procedure again to reference the network, reference the node, which is the pop object, and choose presets are as particles. And we can see that everything looks just like the same with the DOP network. And lastly, what we want to import is head. So we need to put down the geo node here, name it import head, and let's go back to what we did for the slide, because head is also an object that we need to interact with all of these effects here. So the thing we need to put down is object merge. And the object we want to retrieve is out box. So we can see that unlike the slide here, when we retrieve all of the data here, the head was just stayed the same and it didn't move. So the thing is, we are retrieving the data from the first SOP network, which doesn't have any kind of information that's stored in DOP network. So we need to get that information to this object merge node. So the thing we need to do is to add a DOP import here. Not DOP import field, but DOP import. And we need to specify the correct DOP network, which is, in our case, we only have one DOP network. And the object for the object mask is our RBD object 1. And for the import style, we need to choose create points to represent objects. And that imports the information from the DOP network to here. And the last thing we need to do to actually create that effects is to merge the two nodes together using transform pieces. So we need to connect the first import point with the object merge and the second with DOP import. And display it, we can see that the head is here. And when we play the simulation, the head is actually working, doing the same behavior as it did in DOP network. So that's basically all we need to do for the SOP output. And the last thing we need to do, if you remember, is to add texture and shadings. So when we navigate to the material palette down here, we can see all kinds of textures that's pre-installed in Houdini. And what we need to do here is that, if we remember, we have a slide, we have fluid, we have smoke, particles, and we have the head. So maybe for our slide, we don't need it to be super realistic, so we can actually choose anything we want. In this case, I'm gonna choose gold. We're gonna have a gold slide. And for the water here, we want the texture of basic liquid. And I'm not sure about how the head will work when using material, so maybe I'll assign it as a skin, and we'll see if that works. If that won't work, then we can try silver, gold slide and silver head. Okay, so after slide, when we go back to the SOP output and select the import slide node, and we click on the render tab, and we can see that there's a material and we can choose its path. So for that, we are gonna open the the matte folder, and we can choose gold. And immediately we can see that the change texture of the slide into something goldish, and that means we are doing the right thing. And for the flip, we're gonna do the same thing, but we are gonna reference basic liquid. And we cannot see immediately what's going on here, but we will definitely see that change in when things are rendered. And oh shoot, I forgot about the smoke. So I'm gonna go back to material palettes and add maybe billowy smoke here for the smoke objects. So in the same place, we're gonna reference billowy smoke. And for particles, actually we're not gonna add anything here because it's just particle, it's just points. So for the head here, let me try skin first. And apparently it doesn't work, so let me go back to the plan B, which is silver. And we can see that it works perfectly fine. And that's all for what we need to do before going to the render tab. So before we actually render it, we need to do some necessary things to set up the scene, which is camera and light source. So for camera, we're just gonna add a camera to our object interface, and we can see a little camera here. And we can select the camera views through this button. After clicking that lock button here in the middle, we can just control where the camera will move according to our movements, and we can set it to somewhere perfectly precise without using all of the translate and rotate values up here in the parameter. So we have something like that, which is pretty good. And I'm gonna add the light sources, which is an area light. And for area light, I'm just gonna try to increase its intensity, and apparently it doesn't work very well. Intensity is too small, and maybe we'll add it to 100. No, that's too big. Maybe just lower 25, and we're just gonna adjust its positions and rotation. And simply enough, that's a good place to do. And we're gonna add another light that shine on the back side of the slide, which is the spotlight. And we're just gonna put it to the correct place with rotations and translations. And I'm just gonna put the light to the back in order to give some light source to the head and all of the fluid back there. And we can actually adjust its point where the light is gonna go for. So that's pretty convenient. And if we're gonna put it to the precise place, we can always choose different perspective, like front view and back view, top view, to adjust its place. And after we get somewhere we are satisfied, we can change its color, intensity and stuff. And I'm just gonna change it to orange, which is pretty glory with the company of the gold slide. And we can see everything's going on pretty well in the camera viewport. And after that, we can go into the render view and select render frame range. We can confirm that it's from 1 to 50 and set up its resolution, and that's all. So additionally, I want to talk about something that haven't been covered in many places before, and I just discovered that through videos on internet, which is pretty cool to see. So one of the biggest problems about basic liquids, using basic liquid without any adjusting, is that when you go to the render view, we can see that in the first frame everything looks pretty fine. But when we go to another frame in the second half, we can see that it doesn't look like everything that we see in the scene view, which is all of the fluid all over the place. Instead, we only see that a little part of the awkward looking fluid and a big portion of blackness, which is, I haven't discovered why, haven't researched that much, but even when we add the slide here, we can see that there's apparently a dark place. So apparently that's a problem. So according to a video I just discovered, we can use another technique to properly render the fluid, which is use meshing. And after I turn on the display flag for that, we can see that it actually looks like a liquid instead of particle, although it looks very weird, but that's very realistic compared to what we did previously. So as I click into the meshing node, we can see that it consists of different nodes. So let's talk about that from the first place. So the first node we use is something called DOP import, which I've been using for simulating the head in our second SOP network. And we can see that for DOP network, it retrieved the DOP net 1, which is the same. And as for the object mask, I use the flip object, just like what we did using the RBD object for the head. But the import style, instead of creating points, we need to choose fetch geometry from DOP network. So apparently it's retrieving some kind of geometry. And for the next step, we need a node that's called VDB from particles. So VDB is kind of a volume type that can use to generate better 3D objects. And using VDB from particles, you can see that it changed to more of a fluid 3D modeling like shape. And from that, we can change the voxel size, which is the units of the 3D objects, into something lower, because defaultly it's 0.1. I just changed it to 0.02 because what we use in DOP networks are all 0.02. And we can always change its other parameters like point radius scale and minimum radius in volume until we got the right result we want. And the third node we use is VDB smoothed SDF, and which is just a smooth node to smooth out the volume to create all of this fluid. And we need to balance the iterations and its shapes, because the higher the iterations is, the smoother it will become, but the overall shapes will become much smaller and it will behave a little bit weird. So for me, I just choose 4, which is the default. And the last node we use is convert VDB, which just converts this kind of thing to the format we want. And in this case, I convert it into polygons, just like what we did in the first SOP node, which is the polygon of our emitter. And let's go back to the objects view, and we can see that's basically how that works. So as for the texture, the specific texture, we can always change that using the material palette. And we can go to the material interface, and we can see the basic liquid texture here. And we can change that by changing all of the parameters on that basic liquid interface. And we can use all of the things here like diffuse. We can make it brighter. We can change its color because it represents some of the gooey effects, so I can change it to green. And we can see that in render view that apparently we can see all of the liquids and slide without any problems. And as for other elements, we can just play around until we find something that suits our needs and something that's more aesthetically pleasing. And maybe make it saturation lower. And we can always change its reflex, refract, volume parameters and its properties until we got something we like. And we can always go back to the render view and see how it will look like. We can even stay in that view to see how it looks like in real time, so that we won't need to go back and forth. And after that, we just need to click on the display flag for all of the other objects. But I will not include particles because it's just messing with our render and it's not very aesthetically pleasing. So I'm just gonna leave out the particles and let's go back to mantra. And for this time, I'm just gonna render the current frame because render the entire sequence will be extremely time consuming. So I'm just gonna render one frame and let you guys see what's going on in that frame. Okay, I just rendered one of the frames and render it into EXR file, and we can open that file using stuff like Photoshop, and in this case I'll use my Photoshop. And when we take a look at this, you can see that it actually looks pretty good, and it doesn't create any of the darkness that block our view. And for some reason the liquid source exploded with fire. I don't know why, but it's kind of emitting light from it. But that's not the problem. The thing is, we did everything we need to do and the result is perfectly okay for us. And we can add a background here to see it more clearly, and it looks better here. And actually, before I record this video, I tried doing this same effects myself, but using a completely different project files. So we can take a look at the video I just rendered for hours. And I chose a very weird camera angle, but basically everything we need to know here is presented here, and it looks very great. And that's all for today's this assignments video, and thank you guys for watching.